All right, let's get right into it. Today, we are strapping in for a journey to the absolute edge of what's possible, and we're going to tackle one of the most mind-bending ideas in all of physics. What would it actually feel like to travel at the speed of light?
So, this is the big question, right? This is the central paradox we're going to try and unravel today. You've got the universe, which is so vast that these distances should take forever to cross. But at the same time, the laws of physics tell us that for the person on that ship, the journey could feel like it's over in a flash. How on earth is that possible? Well, to even begin to wrap our heads around this, we have to look at the cosmic rule book. These are the two fundamental rules of the road laid down more than a century ago by Albert Einstein in his theory of special relativity. And these aren't just, suggestions. These are the laws that literally govern space and time.
Okay, first up, time dilation. And this one is a doozy. The main idea here is that time isn't this constant thing that just ticks away for everyone, everywhere, at the same speed. Nope. Your speed through space actually changes your speed through time. The closer you get to the speed of light, the slower your personal clock ticks compared to somebody just standing still.
And it's not just time that gets weird. Space does too. This is its partner concept, length contraction. As you speed up, the universe in front of you, the very distance you're trying to cross, literally shrinks in your direction of travel. From your point of view, the destination is actually getting closer to you.
So you see, this is the key. You have this split in reality. For the traveler, their watch, their body, their sense of time passing, that's what physicists call proper time. But for everyone back on Earth, watching them go, that's coordinate time. And as we're about to see, these two clocks can get wildly out of sync. Okay, theory is one thing, but let's make this feel real. Let's imagine a hypothetical scientist. We'll call her Dr. Elena Vasquez, and she's on this impossible ship, a vessel that can actually reach the speed of light. Her whole mission is to see these cosmic rules play out firsthand. And this is her itinerary. We're going to follow her on this 7-hour trip. 7 hours from her perspective, that is. We'll check in at these key points as she keeps accelerating, pushing the laws of physics right to their absolute breaking point.
Just 1 hour in, and things are already starting to look weird. She's at 10% the speed of light, and the solar system is already warping. Mars isn't a sphere anymore. It looks like a squashed disk. And Jupiter's great red spot, it's been squeezed into this thin red line. That's length contraction, right there in front of her. Now she pushes the engines harder. At half the speed of light, the distortion is just extreme. Jupiter is now a paper-thin sliver, and Saturn's beautiful, complex rings have all collapsed into a single glowing thread of light. The solar system is literally folding up in front of her. By the third hour, she's at 90% light speed, leaving our little solar system in the dust. And now, the whole universe starts to change. The stars ahead of her don't look like a field of dots anymore. They're all crowding together into this one incredibly bright point, like a crown of light. That's happening because the light waves from them are literally getting squished, shifting them toward the blue end of the spectrum. All right, this is where things go from just weird to completely unbelievable. We're entering the most extreme part of her trip now. What happens when you get so close to that ultimate cosmic speed limit? Well, the effects are almost impossible to imagine. It's hour 5, and she's hit 99.9% the speed of light. And from her window, our entire galaxy, the Milky Way, just transforms. The familiar spiral arms, they've collapsed into these glowing concentric rings of pure light right in front of her. She's watching 100,000 light years of space just contract into a single image.
And this is where time dilation really kicks in. For every single hour that passes for Dr. Vasquez on that ship,
Centuries are ticking by back home. Her 1-hour hop from this moment on is longer than entire generations being born, living, and dying back on Earth. Her personal timeline has almost completely broken away from the rest of the universe.
So what would we see if we looked through a telescope? It's a total paradox. Her ship would look like it's almost frozen in space. It would be contracted down to basically nothing, and its internal clock would seem to have stopped ticking entirely. For us, she'd just be stuck.
But for Elena, the exact opposite is true. For her, the view is the most spectacular thing imaginable. The entire observable universe, all the billions of galaxies, has been funneled into this one, singular, blindingly brilliant ring of light right in front of her. There's nothing to the side, nothing behind her, everything is ahead. And that brings us to the final step, the impossible moment. Dr. Vasquez pushes her ship to hit the speed of light itself. What does that even mean? It means you start to see the universe the way light itself does.
In that impossible instant, her perception completely changes. She's not a traveler anymore. She's experiencing reality from the perspective of a photon, a place where our rules of time and space just don't apply.
So, what's it like to be a photon? Get this. For a particle of light, any journey, whether it's across this room or across the entire universe, takes 0 time. The distance between where it starts and where it ends is 0. The Big Bang, right now, and the end of the universe, it all happens in one single eternal moment of now.
And that brings us right back to the beginning, to our paradox. Dr. Vasquez's trip felt like it took 7 hours, but in that time, on the planet she left behind, thousands and thousands of years went by. Entire civilizations could have risen and fallen, all while she was just having lunch.
Which leaves us with this one last kind of mind-blowing thought to chew on. If, from your perspective, the journey takes no time at all, and you cover no distance, did you actually travel? Or at the speed of light, is the act of leaving and the act of arriving the exact same single moment?